quantum tunneling, when particles walk through walls. You ever try walking through a wall? Yeah, doesn't work. I've tried. You've probably tried. We all had that one moment as kids where we thought, if we ran really fast, or maybe if we believed in magic hard enough, we could just phase through like a ghost. Spoiler alert, we just end up with a bruised shoulder and a deep sense of disappointment. But here's the thing, if you were a quantum particle, totally different story. In fact, you'd be ghosting through barriers on a regular basis. You wouldn't even think twice about it. And this isn't some Marvel superpower or Hogwarts trick. This is just Tuesday in the quantum world. Welcome back to Fabric of Reality, the show where the laws of physics are less like strict rules and more like loose guidelines the universe occasionally forgets about. And today, we're talking about one of the most bizarre, mind-bending, what? Phenomena in physics, quantum tunneling. Ever wondered what would happen if the universe just decided that walls weren't really a thing? Welcome to the mind-bending world of quantum tunneling, where particles pull off the ultimate magic trick, getting past barriers they shouldn't be able to cross. No hammers, no ladders, no break and enter, just pure quantum weirdness. In our everyday world, if you don't have enough energy to climb over a wall, you stay put. Physics says no. But in the quantum world, particles behave both like solid objects and fuzzy probability waves. That fuzziness means there's always a small but very real chance that a particle will simply be on the other side of a barrier without ever actually crossing it in the normal sense. Think ghost mode, but for reality. It's not just a party trick either. Quantum tunneling is the reason the sun shines. Hydrogen atoms fuse because they tunnel through energy barriers that would otherwise keep them apart. It's behind radioactive decay, the storage in your USB drives, the function of quantum microscopes, and the headaches of microchip engineers dealing with electrons that won't stay put. This phenomenon challenges our ideas about space, time, and cause and effect. Particles don't break the rules. They just reveal the loopholes written into the fabric of reality itself. And while the odds of your entire body tunneling through your bedroom wall are laughably tiny, particles do it all the time. So, buckle up as we break down one of physics' strangest, coolest quirks and discover how impossible events at the smallest scales are quietly shaping the universe you live in. Okay, let's start with the big picture. In our normal, everyday life, if you don't have enough energy to get past something, a wall, a fence, that one friend guarding the last slice of pizza, you don't get past it, no exceptions. It's like a video game where you try to jump too high and just bonk your head on the invisible ceiling. End of story. But in the quantum world, things get fuzzy. And I mean literally fuzzy. See, particles at that scale aren't little billiard balls. They don't have a single fixed position. Instead, they behave like waves. Waves of probability, to be exact. It's like instead of saying, this particle is here, you have to say, well, there's a 40% chance it's here, a 20% chance it's over there, and oh look, there's a tiny chance it's hanging out on the other side of this wall. And here's where the magic happens. That tiny chance isn't zero, which means sometimes it actually happens. The particle is suddenly somewhere it has no business being, and it didn't climb over the wall, it didn't break the wall, it didn't ask permission. It just sort of blurred through and showed up on the other side, like your cat appearing in a room you swore you closed off. The classic analogy physicists use is imagining a ball rolling up a hill. If the ball doesn't have enough energy, it rolls back down. Pretty normal. But in quantum mechanics, the ball is also a wave, and that wave can leak into the hill. And if the hill's thin enough, part of the wave pops out the other side. And when you measure it, surprise, the ball's just sitting there like it's been there all along. Now, I know what you're thinking. That's adorable. But that's not how the real world works. Oh, my friend, it is how the real world works. In fact, without quantum tunneling, you wouldn't be here to question it. Let's take the sun. You know, big fiery ball in the sky, source of life, provider of free vitamin D and occasional sunburns. The sun's power comes from nuclear fusion, smashing hydrogen atoms together so hard that they merge into helium, releasing energy. Problem is, in classical physics, those hydrogen atoms shouldn't have enough energy to overcome the massive repulsion of their positive charges. They're like two people who absolutely refuse to hug. But quantum tunneling says, what if they didn't need to fully climb over the barrier? What if they could just slip through it and boom, the atoms fuse, the sun shines, life exists, and you get to binge watch videos on YouTube. And it's not just the sun. Quantum tunneling is also the secret behind modern technology. Ever saved a file on a USB drive? Thank quantum tunneling. Flash memory relies on electrons tunneling through an insulating layer to store your data. Without tunneling, your phone's storage wouldn't work, your computer wouldn't work, and half the internet would collapse into chaos. In fact, tunneling is everywhere once you know what to look for. It's used in quantum microscopes to take insanely high-resolution images. It's the reason some radioactive atoms decay. And it's even a problem in electronics. When engineers make circuits too small, tunneling starts messing things up because electrons just sneak through barriers they weren't supposed to. Imagine building a bank vault and finding out your customer's money is quantum tunneling out into someone's garage. Now, if this is all starting to feel like the universe is cheating, that's because it kind of is. Classical physics says no energy, no entry. Quantum physics says, hold my beer. But here's what's even weirder. Quantum tunneling doesn't care about time or distance in the way you'd expect. It's not teleportation exactly, but it also doesn't neatly follow the rules of how fast something should happen. There's a reason people get philosophical about this stuff. When a particle tunnels, it's like reality itself briefly says, shh. Let's pretend the wall wasn't there for a second. And while the math to describe tunneling is solid, seriously, you can calculate the probability with scary precision. No one has a neat, satisfying answer for why the universe works this way. We can describe it, we can use it, we can build technology around it, but the underlying reason, that's still one of physics' delicious mysteries. Now, if you're wondering, okay, but can humans tunnel? Theoretically, sure. Practically, absolutely not. The odds of every particle in your body quantum tunneling through a wall at the exact same time are so low that you could wait longer than the age of the universe and still not see it happen. So, you're still going to have to use the door. Sorry. But here's the fun part. In the quantum world, impossible is really just super unlikely. And super unlikely things happen all the time when you're dealing with enough particles. That's why quantum tunneling isn't just some rare trick. It's a constant feature of the universe, quietly running in the background while we go about our day. Think about it like this. Your phone is using tunneling right now to store and retrieve data. The sun is tunneling particles to keep you alive, and somewhere, right now, a particle just tunneled through a barrier for no reason other than because it can. And that's the wild thing about quantum physics. At our scale, everything feels solid and predictable. But zoom in far enough, and reality turns into a chaotic playground where particles vanish, reappear, and ghost through obstacles just to keep life interesting. So the next time you feel like the world is full of barriers, remember, in the quantum world, barriers are just suggestions. The universe always leaves a loophole. This has been Fabric of Reality, where we peek behind the cosmic curtain and find out the universe is basically running on cheat codes. If you enjoyed breaking the laws of physics with me today, hit that like button, subscribe, and share this with someone who still thinks science is boring. Because let's be real, when you tell them particles can walk through walls, they're either going to think you've lost it or they'll want to know more. Either way, we've got them hooked.